Hello everyone, my name is Shruti Singh. Today I am going to present our project titled Gesture Controlled Robot Car using Arduino. This project is a team effort along with me. It has been developed by Shreya Misra, Sivangi Patra, Smaranika Misra and Smurti Sneha Jena. Now let me briefly explain the abstract of our project. This project focuses on the development of a gesture controlled robot car that enables contactless and intuitive human-robot interaction. Using an Arduino microcontroller, MPU 6050 accelerometer gyroscope and Bluetooth communication. Human gestures are converted into real-time robotic movements. The final system is responsive, reliable, and easy to operate. Now let us understand the motivation behind this project. The first motivation is intuitive intersection, where robots can be controlled naturally instead of using buttons or joysticks. Second, we aim to overcome the limitation of wired and traditional remote controllers. Gesture control reduces physical contact, improves efficiency, and increases accessibility. This approach is highly relevant in areas like defense, healthcare, and industrial robotics. Now let us look at the problem statement. Most existing robotic systems depend on wired connections or limited remote controls. These methods reduces mobility and are not intuitive. There is a need for a wireless, low-cost, and seamless control mechanism that can directly translate human intent into robot movement. Our project addresses this problem using gesture-based control. Based on this problem, we defined clear objectives. The objectives of our project are to accurately recognize gestures, establish reliable Bluetooth connection, ensure real-time motor control, and design a low-cost and scalable robotic system. Now let us discuss the scope of this project. This gesture-controlled robot car can be used in robot navigation, assistive robotics, military, and surveillance work, and also as a learning project for students to understand robotics and programming. Next, I will explain how the system works internally. Gestures are detected using the mobile phone. These gestures are proceeded by Arduino. The data is sent through Bluetooth. Arduino receives the data and controls the motors using motor driver. Based on this problem, we defined clear objectives. The objectives of our project are to accurately recognize gestures, establish reliable Bluetooth connection, ensure real-time motor control, and design a low-cost and scalable robotic system. Now let us see the hardware components used in this project. The hardware includes Arduino Uno and Nano, Bluetooth module, L298N motor driver, DC motors, robot chassis, rechargeable battery, and connecting wires. Now let us see the hardware components used in this project. The hardware includes Arduino Uno and Nano, Bluetooth module, L298N motor driver, DC motors, robot chassis, rechargeable battery, and connecting wires. Along with hardware, software is also important. So we used Arduino IDE to write and upload the code. Embedded C and C++ were used for programming. A Bluetooth controller app was used for gesture input, and the serial motor was used for testing. Now let us understand how communication happens. The MPU 6050 sensor communicates with Arduino using the I2C protocol. Bluetooth HC05 is used for wireless communication. Serial communication is used for programming and debugging. Now coming to the most important part of the project, working principle. The user moves the mobile phone. The app converts this movement into commands, and these commands are sent to Arduino through Bluetooth. Arduino processes the commands and moves the robot accordingly. Now I will explain how the project is implemented. Mobile sensor detects the tilt of the phone, and then the app reduces unwanted noise and sends clear commands, and these commands are sent wirelessly. The Arduino converts them into motor movements in real time. Now let us look at how code works. The code starts by setting motor and Bluetooth pins. It continuously checks for commands. Based on the received command, the robot moves in the required direction. Now I will explain the command logic. Each command represents a movement. F means forward, B means backward, L means left, R means right, and S means stop. The motor driver follows these commands accurately. Now let us discuss how we tested the project. We tested the system for accuracy, speed, and response. We focused on smooth control and minimum delay. Coming to the testing results, based on our testing, these were the results. The robot responded correctly to all gestures. There was very little delay. The system worked reliably for a long time. The total cost of the project is around 4,000 rupees. This makes the project affordable and suitable for student use. Coming to the safety part, safety was also considered in our project. All wires are properly insulated. The battery is handled carefully. Motors are used within safe limit. This project has also social importance. It supports low-cost robotics, helps in working safely in dangerous areas, and encourages learning and innovation among students. While working on this project, we faced some challenges: Bluetooth signal issues, sensor errors, power supply problem, and gesture adjustment were some challenges that we faced during the project creation. In the future, this project can be improved further. We can add obstacle detection, camera control, advanced gesture recognition, and artificial intelligence. Now, I would like to conclude my presentation. We successfully designed a gesture controlled robot car using Arduino. This project helped us learn about robotics, sensors, and communication. Thank you for watching and listening. Thank you.
Welcome everyone. We, Shivangi, Shruti, Smruti, Shreya, and Smaranika, are presenting our project titled Gesture Controlled Car using Arduino. This project is based on wireless control and embedded systems, where a mobile phone is used to control the movement of a robotic car. Let us walk you through our prepared project. The working of this project is simple and efficient. The car receives movement commands from a mobile phone application. These commands are processed by the controller, and based on the received instruction, the car moves in the required direction, such as forward, backward, left, or right. Now, let us look at the components used in this model. The Arduino Uno acts as the main control. The motor driver module controls the DC motors connected to the wheels. A lithium-ion battery pack supplies power, and a buck converter is used as a voltage regulator to maintain stable voltage. All components are mounted on a structure with power switches for safety. This setup